we will discuss all the concepts concerning this one, right? So this question actually we are going to solve by three different methods, and through these questions we will understand the concept, right? First method. First we consider current method. Okay. So suppose this is a battery which has a 4 volt potential difference, and there are two resistors in series, then another two resistors in series, and these two are in parallel. We have to find out the current through this resistor, and we need to find out potential difference across this resistor. So two questions are there. We have to solve this question by different methods. First we take current method. Let us consider current through this is I. I current passes through this battery, and it gets distributed in this and in this resistor. Suppose I1 goes through this resistor and I2 goes through these two resistors, I1 and I2. And so of course I will be equal to I1 plus I2. I equal to I1 plus I2. Now see, I1 current passes through this resistor as well as this resistor, and I2 current passes through this resistor and this resistor. Now the potential drop across this resistor will be 6I1, 6 into I1. IR, that is the potential drop, potential difference across this resistor. And across this resistor, the potential drop is 3I1. And the sum must be equal to 4. Because 4 volt is the potential difference across this. So here 0 volt, then 4 volt, 0 volt, then 4 volt, 0 volt, and 4 volt. So now this is the potential difference across these two ends is 4 volt. So 4 must be equal to 6I1 plus 3I1. Likewise in this we have 12I2 plus 3I2 must be equal to again 4. Now from the first equation we get 9I1 equal to 4. So I1 is equal to 4 by 9. From here you get 9I1 equal to 4. I1 is 4 by 9. Now from the second equation we get 12I2 plus 3I2 equal to 4, and so we have 15I2 is equal to 4. So I2 is equal to 4 divided by 15 ampere. Correct? And so total current if we need to find out, then I will be equal to I1 plus I2, that is 4 by 9 plus 4 by 15, which is equal to whatever, how much? So is equal to how much? 32 by 45 ampere. So this is the net current passing through this battery, right? I is equal to I1 plus I2. I1 we have already found from this equation, which is equal to this much, 4 by 9 ampere, and I2 from this equation, which is equal to 4 by 15 ampere. And adding up to we get I is equal to 32 by 15 ampere. So suppose if we need to find out the equivalent resistance, then we can find it out from here. R equivalent into this R must be equal to potential difference 4 volt, that is equal to 4. And so from here we get R equivalent is equal to 4 divided by I, which is equal to 4 divided by 32 by 45, which is equal to 45 divided by 8 ohm. So this is the equivalent resistance. Everything we can find out. This is the equivalent resistance. In this question, however, it was not asked, but if we need to find out the equivalent resistance, this way we can find out 45 by 8 ohm. Now come to the questions that are asked in this problem. Current through 6 ohm resistor. Current through 6 ohm resistor, that is I1, which is equal to, we have already found out, 4 by 9 ampere. So this one. And the second question is potential difference across 12 ohm resistor. 12 ohm resistor, this one, So what is the potential drop across this? So potential drop, potential difference across 12 ohm resistor will be equal to I into R. Current through this one, this is I2. So this will be equal to 12 into I2. I current is I2 here and resistance is 12. Now just put the values. 12 into I2 is how much? 4 by 15. So that is equal to 16 by 5 volt, which is equal to 3.2. So 3.2 volt, that is the potential difference across this 12 ohm resistor. So both the questions are answered, and a lot of things that we can find out for this circuit. R equivalent we have already found out this much, and anything you can find out. Likewise, what is the potential difference across this one? This will be again I2 into this 3 ohm, I2 into this 3 ohm, and I2 you know this. So 3 into this, that is equal to 4 by 5. 4 by 5 means 0.8 volt. So 0.8 volt across this and 3.2 volt across this resistor together, that is 4 volt. So 4 volt potential difference across this, that is distributed in two parts. 3.2 volt across potential drop across this resistor, and then 0.2 volt across this resistor. So that's it. So that is first method. Now let us discuss another method, that is second one, that is potential difference method or voltage method. So potential difference method. In the first method we have considered current I, and we have distributed it in two parts, I1 and I2, and then we have solved like this. That is quite easy. I think you all would have understood. Now we are going to discuss the same problem through another method, that is called potential difference method. Potential difference method. In this case, let us draw another circuit. So the another method that we are going to discuss is potential difference method. In this case, we consider 0 volt potential here, then here 4 volt, here 4 volt and 4 volt, 0 volt. Now see this point, we consider potential at this point to be X and potential at this point to be Y volt. Now see, potential difference across this resistor will be I into R, right? Current we just don't know. So what will be current? Potential difference across this resistor will be 4V minus X. 4V minus X. And so the current through this 6 ohm resistor must be equal to this potential difference divided by the resistance 6. Now the question is this: why we have taken 4V, 4 minus X, 4 volt minus X volt. So 4 minus 6, why not X minus 4? Because see here the potential we have considered 0, then 4 volt is the potential here, and the potential difference is 4 volt. Here we have considered 0 volt, 4 volt, 0 volt, 4 volt. 4 volt is the potential difference across this, across this, across this. Now see, this is at high potential, and this must be at low potential, and this must be further lower potential. So that current will pass from higher potential to lower potential. So this is high potential and this must be low potential. That is why 4 minus X. So 4 minus X divided by 6, that is the current through this one. Potential difference is 4 minus X and divided by 6 ohm resistance. So this is the current through this one. Now current through this one is equal to X minus 0 divided by 3. That is the resistance. Now these two currents must be equal because these two resistors are in series, right? So same current will pass through both the resistors, and so we have this equal to this. The same way, through these two resistors, same current will pass. Now current through this will be potential difference 4 minus y divided by resistance 12, and current through this resistor will be equal to y minus 0 divided by resistance 3 ohm. So this is the current, and these two must be equal because same current will pass through both the resistors. So again this is equal to this. Now from the first equation you can solve it. X is equal to how much? 3 and 6 cancel out, 2. So 2x equal to 4 minus x. So 4 minus x is equal to 2x. From this equation we have 4 minus x is equal to 2x. And so x is equal to 4 divided by 3 volt. And from this we can find out 3 4 is 12, so 4y. 4 minus y is equal to 4y. And so we get y is equal to 4 divided by 5 volt. So we have just found out potential at these 2 points, considering potential this point 0 and this point 4 volt. Now we can solve both the problems. The first one is current through 6 ohm resistor. Current through 6 ohm resistor, and that is equal to this one. Just put the value of x, we have got it here. So in this one or this one, you just put the value of x, you will get current through this resistor. So the first question, current through 6 ohm resistor is equal to, from here we get, or from here we can find it out, x divided by 3, which is equal to x, now this one, so we get 4 by 3 divided by, so that is equal to 4 divided by 9 ampere. Now the next one is potential difference across 12 ohm resistor, this one. The potential difference through this resistor will be 4 minus y. 4 minus y. Potential difference across 12 ohm resistor. So that is equal to 4 minus y, we have found out 4 by 5. That is equal to 16 by 5. So which is equal to 3.2 volt. Again the same answer that we had got in the first method. So 3.2 volt, that is the potential difference. Okay, fine. So by this method also we can find out everything, whatever we want to find for this circuit. Current through this one, potential difference across this one, anything we can find out. So suppose we need to find out the equivalent resistance. That also we can find out by this method. Okay, let us finish here. The third method maybe we will discuss in the next video. I think that will go longer. So these two methods we have discussed. First one by Thurman method, and the other one is potential difference method. By both the methods we can find out anything for this circuit. Current through any resistor, potential drop across any resistor, anything, whatever you wish to find out, we can find out. Okay, so fine. So that's for now.